settings we're going to apply or we want to use on the page. By default, we have the default settings and colors, and we're updating the status on them. Yeah, and then we're almost at the end. Yeah. So we are at the end of the method, and we have initialized a WebKit web view, and it holds a WebKit web frame. And if I just continue, I messed up the display. We have a browser frame coming up. Okay. So the next thing is the abstraction layer doesn't have like an event loop abstraction or types stuff. In contrast, everything gets pushed into the WebCore framework. So for painting, we do have expose handling in GTK, and widget gets exposed, and we will forward the exposed region to make sense for WebCore, and then we start painting in these areas. Event handling works again because we're like this, because we're a GTK widget. We handle all the input events GTK is handling, and we push it into the web view. And this should have shown up in, yeah, actually it shows up in C4, so I can debug event handling without deadlocking myself and needing to reboot my session. So to figure out where we want to look, we can go into the WebKit directive for our API. So it must be the GTK subdirectory and then WebKit, and we know we want to go to WebKit web view. I missed one subdirectory, so WebKit web view, which is actually C++ code because we need to use webcode types, but the external interface is just plain C. And we can just search for the name mouse. Let's search for expose. We have seen a function, and everybody who has done GTK programming should be known to this, or should know this kind of source code. This is getting called once when a class gets created. Ooh. We have a lot of signals. Very much. Did you know we have so many signals? Okay, so this is called the first time a class in the GObject model gets initialized. And we call WebKit init, and we install all the signals we have, nicely documented with GTK doc and even mentioning when it was added. And we can go down to the expose handling as well. So in our class, we want to handle a lot of things, like choose file, script alarm, which is really specific to the WebView class. And for the general GObject class, we want to handle special things for garbage collection and dispose and finalize, setting properties, getting properties. For the widget class, we finally see all this code. So we have a specific handler for the expose event. We do have one for key presses, or key release, button press, scrolling, focus handling. So we can just take a look into the key press event handler. And we know this function, and I'm going to use this as a breakpoint. I'm using GDB again to set my breakpoint. Now I can type continue. And all I have to do here is to press a key, and GDB should halt in this breakpoint. And luckily it does. And I can see who called me, which has a long history, but somehow the window got a key press and figured out that we are the focus item and we need to handle it. So I'm just stopping here. I can see the code which is around me. So the first thing is from the widget which was active, we know it must be a WebKit web view, so we will cast it to the web view. We are extracting the focus controller and figure out inside our WebKit web view which frame was clicked on. And then we construct a platform-specific platform keyboard event. So we transform, or we have an adapter to go from a GDK event to a specific platform event, this time for keyboard. And the constructor actually knows what to extract from the types. So we can try to step in there. Let's try again. Okay, we just remember the GDK event inside this class. The next thing is to see if we have a display, like a view for the frame. We can have frames which were loaded but were never rendered and have no visual context assigned, and there's no point in clicking on it. Actually, it's going to crash if we do. So we have to check if we had frame view, and then we're calling on the frame. We use the class event handler and call key event on it. Okay, so inside the key event handler in WebCore, so we have now crossed the boundary from WebKit code to WebCore specific code, and inside this handler we're now trying to find the node which was clicked on, which is just handled by event target node for document first, and then we're trying to find this node most likely. So we have found the node we want to display, or we want to send this event to, and then we call an editor class to handle this keyboard event. So in case of Chinese, our editor client that we have seen before will most likely get called, and so we can just make another breakpoint, and we see that the first thing this editor is doing is trying to get an editor client, and then it's calling into the editor client. So we can try to step in there, and we have seen that we sent an event from the WebKit layer down into WebCore. It tries to figure out where it sends the keyboard event to, and from WebKit or from the WebCore directory, it calls back into the WebKit world by using this client system. So in this case, for the editor handle input, it's just a proxy method to use the editor client to call back into WebKit code, and we see it's coming from WebKit core support. Yeah, and then we will probably start to do a composition and let GDK figure out how to deal with keyboard composition and continue. So the important lesson from here is to understand how we get a event in the GDK world, convert it into a platform-specific keyboard event, platform key event, then send it down into WebCore to dispatch. And if WebCore needs to get like support from the platform API and higher widget hierarchy, like input method support, it calls back through a client into the GDK world. Okay. So, and in the previous GDB session, I think I got half of them sleeping now. And in the previous session, we have seen that we created a web frame, and in our case, a web frame is just a G object because we want to emit signals like the frame loaded, or do you want to load this page into this frame questions. So we had to make it a G object, and the responsibility of the web frame is to wrap the WebCore frame and to send the signals. And the fundamental concept there's one thing we use a lot. This is this client concept I showed before. So a general rule of our abstraction is that WebCore should not know about types we use in the WebKit directory. But sometimes the code in WebCore needs to interact with the platform-specific GUI and API code. An example, in JavaScript, you can ask for the size of the frame, and you need to make it possible. So we use this client system. In general, it's a pure virtual class. It's the way to do interfaces in C++. And the client gets passed to an object when the object is instantiated. And the implementation actually sits inside the WebCore support directory. So this way we have an interface in WebCore that can be used by all WebCore types, but have the implementation platform-specific integrated into WebKit inside the WebCore support directory. And I can just execute this as well to see that we really use this concept a lot. So I'm just quitting this text editor, and I'm trying to find the code inside the WebCore directory. So I'm fine. So I'm looking in WebCore, and I'm searching for everything which is called client.h. And we do use this a lot for many things. So we use it for editor client, for input method handling. We use it for drag and drop, for context menus, for providing the geolocation to WebCore. Two things I haven't seen before: device orientation and device motion. Scroll bar client for handling scroll bars, but